Hey guys, so today we're going to take a look at imaginary number operations. You want to make sure to watch all the way to the end through the examples. There's something you need at the end of the video to complete your homework today. All right, so with imaginary number operations, we're looking at, is it possible to add or subtract or multiply imaginary numbers as we learned about yesterday? So just a review from yesterday, that imaginary number I is used to represent the square root of -1. So to take a look at some of our examples here, in the first one we have 3i plus 7i. Now, we can kind of treat it like a variable in this case, where you can actually add those together, just like we'd be able to add together 3x plus 7x is just 10x. We just add those coefficients and keep the variable the same. So when we're adding with I, or our imaginary numbers, we do the same thing. So 3i plus 7i is 10i. Now, when we have a regular number like 4 and we're trying to subtract an imaginary number from that, and we can't really subtract an imaginary number from a real number. So in that case, we can't do anything to simplify that expression. It's just 4 minus 2i. In the third example, we have 3i square root 2 plus 5i square root 2. Now, we have to combine what we learned about radical expressions and adding them, but also imaginary numbers and adding. So in this case, we have the same radical expression, or radical part of the expressions, and the parts in front, the coefficients, can be added together. 3i plus 5i is 8i. So if I take 3i square root 2 plus 5i square root 2 becomes 8i square root 2. So see how that works? We have to have like radicals to be able to combine those like terms. And then we add the coefficients, 3i plus 5i, to get the new coefficient. In our last example, we have 6i square root 3 plus 2i square root 5. Can we add these? Well, the problem here is they're not actually like terms. I have the square root of 3 and the square root of 5, so those radicals are different. So in that one, we can't simplify it at all. So the rule for today that we want to keep in mind is you must simplify with I first. And what I mean by that is if we think about what we did in the previous lesson to simplify expressions, it'll allow us to be able to combine these terms. Now, the way that it's written, square root of -4 plus the square root of -9, we'd say, oh, those aren't the same types of square roots. I can't combine those. However, if we use what we learned about I, that the square root of -4 is 2i, and the square root of -9 is 3i, so we simplify with I first, now we can add those together, and we get 5i. In example number 2, the square root of 100 is 10, so the square root of -100 is 10i. The square root of -63. Oh, let's see, 63 is not a perfect square, so I want to do my simplification process from the previous lesson. It becomes I. Now, the square root of 63, I can break that down as square root 9 times square root 7. And that's going to be I times 3 times square root 7. In other words, 3i square root 7. Oh, that's a lot of work there. So 10i plus 3i root 7. Now I can't add those together because there's no radical in the first part, in that 10i. There's no square root of 7 left over. So that is actually my answer. I'm not able to add those together any further. All right, so here we get into more complex numbers where we have a real part and an imaginary part written together. So the rule with these is you can add the real parts together and you can combine the imaginary parts together. So just think of this as, here, let's write it without parentheses. 7 plus 3i plus 5 minus 4i. So my real number parts, I have 7 and 5. And my imaginary parts, I have 3i and -4i. So we combine what we can. So 7 plus 5 is 12. And then the imaginary parts, 3i plus -4i is -1i. So we get 12 minus I as our answer. If we do the same thing in number 4, the difference here is that I have this subtraction in the problem. It's not an addition problem. So I have to be careful about how I write this without parentheses. So the negative 2 plus 4i is the same, but now I distribute the subtraction. I'm subtracting 6, but then I'm also subtracting a negative 3i. So it actually becomes plus 3i. So I have my real number parts, and I have my imaginary parts that can be combined. So my real numbers, negative 2 minus 6 is negative 8. And when I combine my imaginaries, 4i plus 3i is positive 7i. So negative 8 plus 3i is our solution.